Okay, so problem number 2 has an arrow being shot at a 30-degree angle from the horizontal with an initial velocity of 49. So I'm going to make up a similar problem. There's our horizontal. There's our arrow. Let's say this is 60 degrees, and it has an initial velocity of 94 meters per second. And the question asks, what's the maximum height the arrow will reach? So we're looking for this. We could call this dy, I guess. And it's also asking, how far should the archer stand from the bullseye in order to hit his target? So what this is going to be asking for is your total horizontal displacement. We can call that dy. Nope, dx. So both of these are distance problems, and to find them, we're going to want to find the time and then use the distance equations for that. And the best thing you can do is to start by finding your components. So to find the components of your velocity, your horizontal component, so Vox is going to be equal to 94 cosine of 60. And of course, it's going to be different for your problem. And we'll solve that in a second. And your vertical component is Voy, and that's going to be 94 sine of 60. So you could plug those into your handy dandy calculator. Make sure if you're using your phone calculator, you put the angle first, then hit the trig function, then multiply by 94. But for me, I can just type 94 cosine of 60 and 94 sine of 60. And I'm frustrated because I have my calculator in the wrong mode. So let me just make sure that I have it in the right mode. 94 cosine of 60, 94 sine of 60. Alrighty, Roo. So check it out. There's our Vox is 47 meters per second, and our Voy is 81.4 meters per second. Sweet. So that's how you find your components. Once you find your components, you can start to play around. So let's start by finding the time to the top. And I know that at the peak, my final y velocity is going to be 0 meters per second. If I use this with my initial and the fact that my acceleration is negative 9.8 meters per second squared, I can plug into my handy dandy Vy. Nope, this one, Vy equals Voy plus Ay t. So then I get that my final velocity is 0 is equal to my initial velocity of 81.4 minus 9.8 t. Subtract 81 from both sides. And how's that 9.8 attached to the t? Well, it's by multiplication, so I'm going to divide by negative 9.8. And I get that my time is around 8.3 seconds. That's the time to the peak. Whoops. Time to peak. Of course, if I double it, and I get 16.6 seconds, that's the time for the arc, the time for the entire flight of the projectile. So both of these times are going to be really useful. This time will be useful to finding the maximum height. This time will be useful for finding the maximum distance. And in fact, you can use the same equation for both. We can use dy equals Voyt plus 1/2 Ayt squared to find the maximum height. So just plugging in our 81.4 times the time to the peak, 8.3 plus 1/2 negative 9.8, 8.3 squared. And you can plug that into your calculator. Just make sure you follow the order of operations. So this gets squared first, multiplication, multiplication, and then you add it up. But of course, if you have a handy dandy graphing calculator, you can just put it all in at once. So 81.4 times 8.3 plus 1/2, 0.5, same thing, times a negative 9.8 times 8.3 squared. And we get that our maximum height is a whopping 338.1 meters. It's because I made up that number of 94. That's a very fast arrow. So that's how you can get your dy in that case. You want to first find your time, the time it takes for your your vertical velocity to drop to 0, that's the time to the peak, and then you can use that number, plug into this equation, and you can get the height that it is at that time. If you double the time to the peak, you get your time for the arc. And so you can use that time to, well, just to plug into the same equation and to get your dx, your total horizontal. The handy thing is that this ax, that's just 0. So this whole thing is just 0. It's sort of like an arrow. That's just 0. So this is really dx equals our vox, which was 47. And our time to, not the peak, but for the entire arc, 16.6. And this, very simple, it's like distance equals rate times time. 47 times 16.6 is 780 meters, very far. 780.2 meters is our dx in this case. So you can use this example to solve the very similar problems, just with different numbers.